Hey, so a quick review today. This is a $80 hot air soldering station I bought from. I bought it on Amazon because I have an Amazon Prime account, and therefore I tend to try and buy lots of things on Amazon. But this is one of those. I don't even remember who made it, but it's one of those very inexpensive combination hot air soldering station slash. This one has a soldering iron as well. It's Kendall 2-in-1 Smart Hot Air Soldering Iron 898D. So there's a whole bunch of different companies that sell these. They're all 898D. And there's a few reviews of these floating around on the EV blog forums and other places. But I figured I'd just throw my hat into the ring, as it were. So I bought, there are two versions of this. There's one that does not have a soldering iron that is about like $65, and there is the version that does have the soldering iron that's about $82. And to be entirely honest, it wouldn't surprise me if I never actually wind up needing to use the soldering iron on here. But there are a very few situations where having two soldering irons at once, you know, because this is a Heiko FX 888. And it's a decent iron. It's not like a Metcal or anything, but it's livable. But the soldering iron on these is typically kind of like flaming crap. Like you use it for 20 minutes and the handle is almost too hot to hold. But very occasionally there's a situation where you want to have two soldering irons to, you have your two irons and like you can be picking double-sided components off a board or something like that. I have played with hot tweezers in the past, but unless you spend a lot of money on them, they tend to the two tines tend to kind of wobble too much to make them really usable. I mean, you need a fairly decently well-machined hinge, and most of the cheap ones, like I had a $50 pair of hot tweezers at work once, they're kind of crap. So, usual Matryoshka packaging. Hey, we heard you like boxes, so we put a box in a box in a box. Blar, blar, blar. This is fairly livably packaged. It has a, little short Chinglish Operation Gun. Blah, blah, blah. Open the power and display show dash 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 and enter standby state. Set up the temperature and take in the handpiece. The station will enter warm-up state. Adjust airflow when the temperature steady while using now. Not use it. Please put the handpiece on the holder. The station will stop warm-up automatically. When the temperature is below 100 degrees C, the station will show dash dash dash. The station will enter at the standby state. When the temperature lower than 70 C, the station will indicate standby state and stop working. Long not using. That's pretty funny. It looks like it's 700 watts. Apparently it has brushless balls. They're claiming plus or minus 1 degree C, and the thermocouple I have tomorrow will definitely be used to verify that. So it looks like they make two of them. They make the 878 series and the 898 series using Samsung microcomputer processor and PID technology. That's nice. So they have a little, there's like the disassembled view of the hot air gun and the soldering iron. And then, the display shows value will keep blinking, then are at the temperature setting state. Amused. Anyways, so here is what comes out first. So we have a plastic soldering iron stand. This is the little handle holder. So the hot air gun on this is captive, I believe. Yes. And this is also one of the stations with the hot air gun. The fan is in the handle rather than. There goes my stencil. So here's the box, and this is going to be a review down. So here we have the box, we have the gun, and then here is the soldering iron. So it's a very typical kind of Heiko-ish knockoff iron. It comes with a very sharp, pointy tip, which I've never found a pointy tip to be of use really anywhere. I pretty much always want a smaller spade tip, or something along those lines. Stand is decent. It's all plastic except for this metal base, which I suppose is there to keep like hot dripping solder from, I don't know. And it doesn't come with one of the little brass sponges, but I don't really use those either. Anyway. So this will probably actually find its way onto a shelf and then just live there. So, captive gun, that's a little annoying. It'd be nice if they could put a connector on here. So, is that an extra heating element for the soldering iron? Huh. No kidding. Well, that's awfully nice of them. And now I've pulled the little fabric sleeve off. So yeah, this sure looks like an extra soldering iron heating element. Yeah. So yeah, this is very much Heiko style, where they've got like the, you know, the slip over thing. Actually, so I have here genuine Heiko soldering iron tip that I bought at Fry's. So, sure looks similar. Similarly sized. I think I need to, so there's like a metal shim in here, which is what makes it fit snugly, and this actually winds up being somewhat crucial for thermal transfer. So this does, it appears to just be a very snug fit. They don't actually have the little metal shim in there. But the other thing you notice is that the genuine Heiko has got a ceramic heater, whereas this is a metal heater. But yeah, it looks like it may be arguably Heiko compatible. Yeah, so you can see it's just like a little metal roll-up, and then that just serves as a shim to improve the thermal contact so they can be shitty with their manufacturing tolerances. So actually, so that is much looser than the Heiko. So there's almost no play. So I actually kind of strongly suspect that with the shim on there, the Heiko will not fit. And that is an accurate guess. Well, that was pointless. So anyways, you can see that the hole in here has got a lot of play. And then they're taking that up with the this little metal sleeve, which should be delineated from expensive Chinese scrap, which tends to actually not really be that crap a lot of the time. You can generally get things from China, things you can get from America. You just have to pay the same amount. So here we have a 5-pin connector, which, considering there's only 4 leads coming out of the heater, one of these I would guess is probably the tip ground. Yeah, but you can see here it's actually labeled, oh no wait, there are 5 leads. Yeah, see here's this spring here is the 5th lead. Derp, I can't count. So there's a send plus and send minus, heat plus and, or just heat and heat. So I wonder if this is a proper thermocouple. It probably actually is. But this is fairly decently made. I mean, it's about what you'd expect from most of the Heiko knockoffs on the market. At least there's a PC board in there. It's not just like sitting. And this actually sits into slots, which is quite nice. Seems like the spring just sits against the PC board, which is not wonderful. Should probably take the rest of this off just to make this go together more easily. Alright, moving on. So, this stuff out of the way. We have 3 nozzles. I must confess, at work I put the smallest round nozzle on my hot air soldering gun, and it's never been taken off. Pretty much. That's nice. These are not. Oh, that's nice. So they've got 2 little indentations, and it's a bayonet lock thing, which is definitely better than the screw lock thing that the one I have uses. I'll try the medium-sized nozzle, just because the screw lock thing, you wind up trying to change tips when it's hot, and it's just like, yeah, no. And this is supposedly a tip removal tool, but I've never been entirely certain how it works. I've always just, you know, pliers! Tips off when it's hot. Also, I don't know if you noticed, but it looks like I just scraped a whole bunch of the nickel plating off of this. So, here's the controller. Kendall 898 Plus. 898D Plus. So we have the 2 sides. We have air, buttons, enter. So I'm kind of curious as to how you select which LED display is being used. Another thing that I expect is that most of these, they turn off when the handle's in the handpiece, and they do that by virtue of a magnet. So, yeah. So you can, I don't know. So there are magnets in here. So there's like a reed switch somewhere in the handle. And what happens is, when this is set in here, you know, the reed switches are close to something in there and it turns off. We also have this, which is, I think, just a guard. Yeah, so that's just a kind of a wanky little don't burn your fingers thing. Oh, it also holds the case together in part. Because I don't know if you can see, but it's kind of opening up a little bit. So this is actually fairly busy. So we have our little PCB here. You obviously have, there's a whole pile of leads here. So we have several connections. That is E-ground. So you can see actually there's 3 braided, you know, kind of glass shielded braided leads here. One of which, this one that goes down here, is actually connected to the casing. We have 4 leads going into the heater. So these 2 are the sense leads, because it says sen minus and sen plus here. These 2 go to the heater in general, and it looks like there are some sort of connectors, probably, you know, push-on connectors down in there. And then in there you can see the little metallic form, and there's a mica, or it's probably mica, or like a hot heat-resistant paper wrapping around there to keep it insulated from the casing. And then here we just have a little 24 volts at 0.18 amp, just a little spinny blower. So that's how these are, you know, that's why they've been getting, you know, cheaper and more accessible, is because now, rather than having to have the diaphragm pump in the base, they just use a little DC blower in the handle. And then you can see there's actually, this is the little rubber gasket. So that's actually quite nice. Look at this, there's actually metal inserts in the handle for the screws. I'm actually very impressed by just that fact alone, considering how cheap this thing was. You know, I mean, I guess maybe they did that because they expect the handle to have to be disassembled and reassembled a number of times over its lifetime when you want to replace the heating element. But still. So those 2 screws hold the back together, and then the tip is actually held together by this. And this feels like, I don't know what kind of plastic it is, but it's definitely some sort of obscure, you know, high temperature polymer thing. So this stuff will melt if you leave it, if you leave your hot air gun overnight. Don't ask, trust me, I know. So the last thing that I need to find is, oh hey, so the screws for mounting the holder on here are actually already on here. And one of the nice things I noticed is there's screws here, and then there's screw holes on this side, so you could presumably take these out, flip this around, and put it on the other side. Can't quite see down to where the magnets would have to be stuck, but they're in the sides. And you saw the reed switch in there, which I probably should have pointed out more directly. It was the thing silicone gooped down to the side of this. So I think the way these work is the heater in the hot air guns are generally... well, the heater on the hot air gun pretty much has to be 120 volts, because otherwise they wouldn't have any way of... the transformer in here is nowhere near big enough to handle 700 watts. So, on the back we just have input, 700 watts, 110 volt AC, fuse is 6 amps, and that works out about okay. It's just a little glass fuse. This whole thing just seems to be back panel held on by these 4 screws, front panel held on by those 4 screws. So, let's take it apart before I even bother turning it on. Otherwise it might catch fire. These are also sheet metal screws. The only thing that has machine inserts are is the handle. Then I guess they don't expect you to disassemble the housing. Alright. So. Well, there is not much to that, is there? Somebody's failed at heat shrink. The mains are properly, the earth is bonded properly. So, here we are. We have power comes in on these kind of remarkably short leads. You can see the earth actually runs right down to a tab, which is under this screw going to the transformer, and that's very nice. You can see here we have a transformer. This is a 110 volt only transformer. No luck for you English people or Australians who want to buy one of these. I think they'd probably make one with a proper transformer for other line voltages, but not this one. So you have a 26 volt, a 34 volt, and a 10 volt output. That's kind of interesting. So I think this does not say... This is completely bare. There is no markings on this at all. But looking at the heaviness of the windings, red and red, there's red and red primary, and there's red secondary. That's insane. Well, the blue and blue is fairly lightweight, and the yellow is fairly lightweight, and so if we look here, we can see this is a split bobbin construction, and this has to be the primary because the other 2 taps are coming off of the secondary. So basically one of these is primary and one of these is secondary to give you the proper isolation. So because only one connection goes to the lower half and the other 3 connections come off the upper half, the heavy wires have to be the primary. I'm not sure. Anyways, I'll give them this. They certainly didn't skimp on transformer cable length. So power runs in. Let's see. So this. Okay. So we can see here's our hot lead, and it goes into one side of this switch, and then it runs over to one side of this switch. Okay, I see how this works. So these two switches, they're half in parallel. So we can see that either one of these switches is going to connect. Either one of these switches is going to connect these 2 points here, which is going to basically supply power to the system. Which I believe... Yeah, okay, so power into the board runs into this port. What are you... Is this actually... It's glued on, that's terrible. Or the glue got on it somehow. So... It's not wire cutters. Power comes in, runs to this socket here, and then this right here runs to the transformer, and this right here runs out to the heat gun, which does not have very long cables. Another thing you might notice is all of these are glued down, which is nice. So, wow, look at this. This board is single-sided. They solder the parts down to the... Yeah, it's a single-sided board. Go figure. So, and then here we have the two returns from the... So power comes in here, runs to these two connectors, one of which goes... This one right here goes straight to the heat gun, and the other one goes to the transformer. And then I suspect these are like triacs or something. BT137. And that is a BTA16. I think that's 137. Neither of which have any clear manufacturer marking I can make out. That is definitely a BT137, and that is... Oh no, that one's an ST BTA16. And what I'd guess is happening here is I'd guess that these two optos are basically isolating the main stuff, which is going on over here, from the low voltage stuff. Because remember, I'm pretty sure that all of the connections for the soldering iron have to be basically safe. You know, it's all low voltage. So further down you can see this is the... So over here we have all of the various analog sundries coming in from the heat gun. And then we also have... what is that? Okay. And then here is a... this is a potentiometer. Just comes in there. And then devices we have down here, we have a couple Qs. Well, there's a Q3. There is a WY4. What is this big TO220 device? That is a TIP122, a TIP122. Over here we have a bridge rectifier. And then there is an L7805. Man, they sure love their 7800 series regulators, don't they? And then this is an LM358 from ST, which is nice. And then up here we have an ATMLU250. So but it's marked 24CO2, so that's probably like a Cal EEPROM or something, or stores the previously set temperature or something along there. These optos are both MOC3041. I'm actually not too sure why there's two of these, because it looks like the transformer is pretty much always energized, because remember, the transformer is also running all of the logic, probably off this 10.6 volt output. So I don't really see how they could be basically kind of dimming the input of the transformer, if you will. Whereas, you know, a triac, you know, basically a triac light dimmer, for all intents and purposes, is generally the kind of the commonly used thing to limit the power going into, you know, just a purely resistive heater. One thing of note that I said earlier is this board is entirely one-sided. It's also interesting they have very nice, the feel of these buttons is very nice. They're very nice, loud, clicky buttons for people who like that. And then you just see these two connections here are just telling the micro which switch is on. The micro is, incidentally, indeed made by Samsung. It is a S3F9454BZZ-DK94. Another thing of interest is there are two 10-turn pots. These are both Chinese-born knockoff. They're BAOTER branded 3299. Sorry, 3298. 3296. Yeah, so they're just two 10-turn pots. This one is 122. Oh, no, sorry, this is 102, and that one's also... That one is also 102, so they're both 1K. You can see there's that little bridge rectifier, the dip bridge rectifier, LM398. Let's see what these transistors are, these little TO92 devices. 2N3904, no kidding. And then that one is another 2N3904. So these are just general purpose switching transistors. So one thing of interest is that I only see one IC that could possibly be being used for the, basically the thermocouple or the thermistor inputs. So I'm assuming they're thermocouples. I guess they could be thermistors. I'm not too familiar with thermistors. I didn't know they go that high in temperature. But I would bet that's an op-amp just based on the fact that I don't know how else they'd be amplifying that stuff. And then I bet there's a lot of linearization going on in the IC. The IC is in a dip socket, which kind of surprises me. Another thing of interest is all the caps on this board have their values marked. Like up here we can see 104 400V, 104 400V. These are probably across there. Which is quite nice. I mean, I wish they had done that for the resistors. They may in fact have, and it's just under the resistors and I can't see it. Which they actually have. That one says 22 something. So that's quite nice. This is definitely very, very, very kind of the opposite of the stupid asshole scrub the numbers off the chips thing. Where it appears that, yeah, that one says 6.8K. It appears that all of the resistors actually have their values marked on the board. Wow. What the hell happened there? But yeah, so it seems like it's pretty nicely made. I mean, they're not high quality parts, but at least they seem to have put some care into putting it together. So, I mean, it's a nice little transformer. I mean, they've obviously got the split bobbin for safety and all that other stuff. Anyways, let me put this thing back together. So you can also see it appears they have different transformer mounting options. So you can see there's glue everywhere. I mean, look, they glued the nuts that hold this back on. They also didn't do a very good job heat shrinking it, but it is heat shrunk. Okay, so let's see what happens. So it appears it has gone to sleep. It also appears that it's sensitive enough that this doesn't really matter about orientation. So it looks like it's set to 300 degrees, and I would assume that's the current temperature. And you can vary the fan. Look at how much faster it heats up. Oh, that was interesting. So one of the things these things do that has been kind of recorded on at least some of the EV blog forums is they bullshit. So you saw how it was like 280 and now it's set to 300. And I don't know if you can make it out, but it's definitely pulsing because the light is flashing. So one of the things these are fairly well known to do is to completely fudge their numbers. So basically whenever it's within a certain closeness of the actual target temperature, it basically just kind of says, okay, we're going to call that the target temperature. So I just turned it off. It's definitely the temperature. It's moving a fair amount of air too. I mean, I can blow stuff around my bench pretty easily. So that's decent. So let's see what the settling behavior looks like when it comes into temp to settling again. So I'll turn the fan up. Yeah, you see it just jumped from 204 to 200. So the numbers, so I have a thermocouple temperature sensor that I'm going to use for the hot plate stuff coming tomorrow. And I will definitely be sticking that in the airflow path. So if you put the handle down in the holder, you can see it starts dropping pretty rapidly. So what you do is you just let it sit. It's currently drawing 9 watts incidentally. Jumped up to 11 when I turned the fan up all the way. So you can see it got down to 100 and it turned off. So you can see now it's basically in standby mode. One thing I did notice is that if you have it on and it's up at temperature and you turn the power switch off, it just turns off. It doesn't, like for instance, I have one of these, a bigger one at work, and that one you turn the power switch off, and if it's hot, it'll spend a few minutes cooling itself off. You know, even if with the power switch off, it'll still run the pump, which is a little, I'm not too thrilled about that behavior. Incidentally, it is really pulling 600 watts right now. The lights definitely, you can kind of tell the duty cycle by the light flickering. If I set it to 350, it's 124 watts right now. So I don't really know, I mean they said PID, and I don't know how, to the extent to which I believe them. But it's definitely, the ripple over time is very interesting. It's about 100 watts, now it's 89, now it's 109, now it's 89, now it's 74, 95, 106, 109. So I'd actually, this is a good application for playing with my, my power meter. You can see this little thing flashing down here, which I think, I don't know, that the heater, that's the heater state. Okay, yeah, so that dot seems to be on. They're using that decimal point to tell you the heater's on, and it's drawing 603 watts. So that's kind of nice. I really wish they had used one of these other dots as like a properly put in the handle, or basically a station detected light. Because I'd worry that if you put it in one of the positions, it wouldn't properly detect that it's holstered. But yeah, and it drops down to 9 watts, back up to 608, 609, 610 watts. There's interesting. You saw how much it overshooted? So the set point is 300. So that's, I'm going to put it on the station. Alright, look, it's actually 315. But they say 300. So look. So that's what I mean about them bullshitting. So the digits, the display is lying. Basically to make it look like it performs far better than it actually does. Which is why I really want the temperature sensor. I mean, you saw it, look at it, it just... See, 300? Nope, it's actually 320. But no, it's 300 really. No, it's 287. So that's really my big complaint about this, is definitely the fact that the base station is completely unabashed about completely bullshitting the performance numbers in order to basically make the system look like it performs better than it actually does. The performance of the system may in fact be completely adequate. In fact, I suspect it is. There's not, the hot air soldering gun is pretty, it's just a hot air soldering gun. But the fact that they felt the need to fudge the numbers like that, I wonder if there's like a hacked firmware for this that might, fix that. Let's plug the soldering iron in and see how it works too. So one of the things I'm kind of curious about is how does, it seems like this is only good for one of the displays. How do you switch between them? So if I set them both on, Okay, it's just sequentially. So we can see that that's set to 300. So again, it looks like we have the heater. So I bet this does the exact same thing that the other one does, with the bullshitting about the temperature. Oh, and it's smoking a bit. I don't know if you can make that out, but it's definitely wisping. A little bit of plasticky fumes from the first power up. And right now it's running at 48 watts. Turning the power off for the hot air station when it's not on doesn't affect the power usage at all. 48, 48. So you can see that they're bullshitting again here too, because you can see the regulation. I mean, look, it's obviously drifting up and down due to the duty cycle variance. But the numbers, they're bullshitting you there too. 10 watts, 37 watts, 48 watts, 37 watts, 9 watts, 14 watts, 41 watts, 48 watts, 22 watts, 6 watts, 23 watts, 47 watts. Yeah, so the power usage is just going up and down and up and down as the system kind of, it looks like it's oscillating actually. I wish I had a fairly fast temperature logger. But the fucking display is lying. It's a liar. Lying liar. See, it's actually 292. So, watch. 200. See? It's not at the temperature that it claims. See? So they've got like this snapping thing going on, which I find, it's just, I mean, it's like, really? I mean, I want to talk to the engineer who decided that, who was willing to implement such bullshit and just smack him upside the head. But I mean, you know, so the kind of the obnoxious bullshit aside, it seems like a perfectly legitimately usable soldering station. I mean, internally it's well constructed, everything's glued, it's got proper earth strapping. And I'll just have some stuff tomorrow, you know, I'll just stick I have a thermocouple thing coming, which will probably also be featured in the teardown. And I will stick it in the airflow and maybe rub it up against the tip and we'll see what happens. So I don't know if you can make that out, it currently says 27 degrees C. So this is just kind of my curiosity about the accuracy of this SMD rework station. There is a little bit of irony going on here, like, look Ma, I'm calibrating my cheap Chinese instrument with my other cheap Chinese instrument, but you know, I think this is probably going to, in general, be a bit more accurate. You know, I need to put together some sort of stand to hold this, because that's... I have trouble believing there's that much variance. Let me figure something out. Okay, so I've just propped the thermistor bead, excuse me, I keep saying thermistor, the thermocouple bead right up in the center of the airflow, and now I'm going to just turn the system on and we'll just let it sit. Well, actually let me turn the air down. So I'll just have that propped up so you can see basically the bullshit. Look, it's already at 377 degrees Celsius. It hits 400 degrees. This is in Celsius. So the only thing I can think of is they've got, you know, in there they have their little... Look at how much it overshot. It overshot by 100 degrees C. That's nuts. So what I think is happening is they have their heater, which is, you know, that little ceramic thing I showed earlier. And I think in the middle of that heater, you know, there's this heater, and they stick their temperature probe in the middle of it. And then what happens is they heat up until that temperature probe hits the target temperature. But what's going on is, because there's a lot of thermal mass there, by the time the temperature probe is up to temperature, the actual air passing through is much hotter. The rest of the heater has heated up a lot more, and then over time the heat seeps into the, you know, basically the whole thing begins to come into thermal equilibrium. I mean, as you can see, it looks like it's now that I don't have issues with holding it, it's settled in pretty nicely. It's definitely oscillating, and it's definitely also 10 degrees hotter than it's supposed to be. But man, wow, 100 degrees C overshoot. Wow. That's really quite abominable. I really can't well, I mean, there's no way I could possibly recommend this thing, considering that massive, you know, sorry, I just bumped the bead had moved a little bit, I just bumped it back. I mean, considering the massive overshoot, I don't see how I could possibly recommend one of these. I mean, if it regulated within like plus or minus 5 degrees, I could deal with the display bullshit, you know, just kind of go, oh, China, ha ha ha. But, you know, the fact that they completely apparently forgot to account for the thermal coefficient between, you know, the difference, you know, basically the thermal, what is it, the mass. They forgot to account for the thermal mass, and as such, you know, the system, you know, overshoots the target, you know, its set point by 100 degrees, you know, when you power it on. That's just unacceptable. I mean, it's, and the intentional deceit, you know, the specific, you know, desire to make the displays read falsely on purpose to make their product look better. You know, I mean, the 10-degree difference could be blamed on, you know, calibration. Let's see if I can't find it. There we go. So that's a hard drive magnet. Let me just do that again, because I have trouble believing it actually was it's that bad. I mean, you can see here how because of all the thermal mass, the readout temperature is significantly lagging the actual air temperature. The air is only 80 degrees, but the readout temperature is 108. So what's going on is, again, it can't cool the mass as fast either. Let's see. Oh, also it looks like I may have bumped. It's hard to hold in there. Why don't I use a bigger tip? Oh, I see what's going on. The thing is wandering around my little prop-up stand. So let me, where did I put the other tips? There it is. Why don't I do it with the tip off? That might be a good way. Because these are bayonet lock, I believe, yeah. So I just put some dents in that one. Wonderful. So, let's just look at the airflow out of the actual heating element itself. We'll kind of flex this so that it sits in there a little bit better. So the problem seems to be twofold. It seems that the actual heat gun is kind of, the fan in there, actually one of the other complaints I have about this, I have one with the air compressor in the base station. And one of the problems I have with this is that the fan makes the whole thing vibrate a lot. So you kind of wind up with like that tingly sensation in your fingers after holding it for a bit. So anyways, that, with any luck, will hold it considerably more steady. Right. All right. So, heating up, you can see how the temperature of the readout temperature lags significantly. You can see we are up to 389 degrees, 401 degrees Now it's coming back down after it's overshot grossly. Alright, so the two thermocouples agree too, which is nice. Now that one's hotter. I'm trying to see why. They're probably in different sections of the airflow. But I mean, yeah, so it seems... Oh, hello, what's going on? Is it having its shit fit again? It's centered. What the hell? That's interesting. It seems like there's some offset between the channels. Or could it be between the thermistors? So that is not touching. Oh, no, that appears to be accurate. I mean, they more or less agree. 1, 2, 2. So I think I'm in kind of a cold portion of the airflow. Ah. Seems to be consistently 50 degrees high. It's really that hot. So it's interesting that it seemed to regulate better with the nozzle on there. I suspect that with some orifice restriction, the thermal difference between basically kind of the internal heating element, which is probably partially cooled by conduction from the airflow. You know, because there's much more airflow now than there is when you put one of these nozzles on there. Incidentally, as you can probably tell, the plating on these nozzles is just peeling off. Really shit quality. It's already rusty on the inside a little bit. Let's see, let's switch settings. Yeah, that's sitting right around 340 degrees. Let me try putting this nozzle back on, and we'll see if it regulates any better. Whoops. Gotta get it lined up. Where are the spots there? So. Ooh, that's warm. Thank you. That's warm, thank you, Captain Obvious. Get the bead into the outlet. No, the two channels agree, that's nice. And this whole thing is walking. So it's pretty noteworthy that this thing seems to regulate quite well once it's settled. There's just a horrible startup transient. I wonder what the... Just turn the airflow up. Oh, hello, overshoot. Remember, it's still set to 300 degrees Celsius. It's 50 degrees too hot. And now it's running consistently 40 degrees too hot. It looks like it's already oscillating right around 3... No, maybe not. Yeah. So the only thing I can think of is the temperature sensing element is somehow being like cooled before, or is located too early in the outlet airflow. Let's down to 2. It's probably going to overshoot just because it's just the thermal settling. But it'll probably come in a hell of a lot closer. Oh, incidentally, look at that. I just lost one of the segments on the LCD, or the LED. So the only thing I can really think of is that the loop constants in this thing are, like, grossly mistuned. I mean, for the most part, I mean, given once you understand the extent to which it's out of cal, I don't see it as being a particular problem, simply by virtue of the fact that it seems stable within about 3 degrees once it's settled, but they have their massive overshoot issues. And frankly, I mean, even that, assuming you're looking at the board when you're reflowing and it's usable, I mean, I'm not going to send it back just because that's too much work, to be honest. And I can use it. It's another one of those, you have to know the caveats. Yeah, it looks like I lost a segment. It's running consistently 30 degrees too hot. Yeah, anyways, so, So I spent a while yapping about how I like chisel tips with these on my soldering iron last night, when I was shooting the earlier section of this video, and it turns out I actually looked in the bag again, and it turns out this actually comes with quite the variety of tips, just, in the box. I kind of missed them when I was in the first batch. So I mean, here we have, you get a, here. You get 2, here's the point that comes on there. You get 2 different tapered points, slightly. You get a hot knife tool, and then you get a, that's a hoof tool, and then you get a chisel tip tool, and that's the one that I'm going to put on there, because it's the only one So these have the same issue. It looks like I have to. So it seems like they're expecting you to pull the metal thing in here out. How are you supposed to get it out? I have no idea. Very carefully, I suppose. So. Now it doesn't fit anymore. Alright, so they've included tips which are either too loose or too tight. It doesn't fit. Huh. So they included a whole bunch of tips, but it looks like some of them just don't fit. The hell? So correction, it actually appears that some of the tips they sent don't have insulating sleeves and are loose and rattly. Some are, and yet some of them, all of the sharp pointed tips do. They are quite snug. I don't really get it. I mean, these three tips are all snug. This tip, falls right off. And I think you can probably extrapolate that the thermal connection for these tips is just going to be shit. They're not going to have any thermal, they're not going to, the tip is going to be very strongly decoupled from the iron. And they're also the wrong diameter. I can't just stick the shims in these tips. Going down. I managed to not trip the magnet when I put the thing in there. So, that's rather irritating. I could have at least sent all tips that are actually compatible with their iron. So yeah, kind of a turd. I mean, I guess I'll hold on to it just because I don't have another hot air station and I don't want to wait for another one to come in. And I can use it, I just have to account for the fact that it's not reading out correctly. Another thing that might be worth noting is that I wonder if... so here's my actual Heiko. Wait, that's not what I meant to unscrew. This one has been well used. So, that's actually fairly snug. It's actually quite a good fit. So, it occurs to me that even if I can't use some of these tips on the actual iron they're supposed to be used with, they seem to be snug enough to be usable on the actual Heiko tip, the actual Heiko iron. Though I'd also gamble that the actual Heiko iron is probably the tips that you buy from Heiko themselves are much better quality. They may be pure copper internally instead of brass or probably steel or God knows what. It wouldn't surprise me if they cut corners in there somehow too. I mean, selling this for 80 bucks is kind of amazing. I may try and fix that display issue. I just thought you just see it soft. It's kind of irritating. I don't really care. It seems like these sort of things would be great if people bought one of those and there was like an open source electronics, an Osh hardware, controller board replacement you could drop in there for like 40 or 50 bucks. I mean, there's not much on there. But anyways, yeah, so there's a kind of a really rather tragically pathetic little hot air soldering station / minor disaster zone. So because I'm curious, I want to see if I can get in and figure out how to get access to either the thermocouple or thermistor. I'm not sure which this uses. And then use the strip chart recorder on my scope to take a look at it over time and kind of see what the regulation actually looks like rather than what the bullshit display shows. Also, I may be able to fix the broken segment in the display. Another mod I'd really like to do is switch the magnetic turn-off to like a switch on the unit, because that way you could turn it on and let it stabilize and you wouldn't have that turn-on transient issue. So, everything else aside, one thing I do have to say about this is they certainly gave me plenty of wire. I'm quite appreciative about that. Also, here you can see, looks like this is the earthing for the tip. Actually, ooh, now that's a design flaw. That's not earthed. Is that connected to here? So, so I think, because this, isn't earthed either. It is, I just was making a bad connection. So it looks like the earth to the handpiece runs through the chassis, through the screws. That's terrible. Alright, I'm gonna have to fix that too. Fortunately, I have some little crimp lugs. Alright, I'm buying fucking metric. So here's our board. So first of all, so this is not very well, the isolation gaps in here are not great. So up here, this is mains. These two are the mains. And you can see mains goes from here to here, here to here. And then this goes over to the triac. So this output here is the triac, I believe, for the hot air gun. Whereas this is just going to the soldering iron. So it looks as if well, of course, yeah, the transformer always has to be on because the electronics are run by the transformer. So you can also see we've got, remarkably enough, there's a pin out of the micro, which surprises me. SCL SDA. What is using? Oh, of course, it's the EEPROM. And then this looks to be it's a TM1620. Let's see if I can get that. Which I believe is the. It's just a LED driver. This is, I mean, this is great. I mean, you can see on this board, they've actually got outlines of the components on the other side. It's with the resistance in them. That's a pot. So this is earth from the look of it. So it's got a 10-bit ADC. So I think, just based on what I've seen, it looks like they're using pin 2, or wait, I'm looking at this backwards. Okay, yeah, so this looks to be ADC 0, I think, is the handle input. And then we have S1, S2, nothing, down, FAD, set, FC, LA something. And then these are used for I2C and the SPI stuff. Okay, so So I'm starting to suspect this is a thermistor because they're directly converting on it. Okay, so right now it's scaled, so roughly the bottom division is 100 degrees Celsius. So it's currently cooling down. And one thing that's interesting is that the fan will kick off at 100 degrees C, and then the temperature will go back up. So the fan just turned off because it's done quote-unquote cooling, but there's still so much hot stuff in there that's not directly in contact with the thermocouple that it then jumps back up to maybe 150. And actually, if you take the thing off the stand and put it back on, I can see right now it's 120 degrees roughly. And that was after the fan had come back on a little bit. But anyways, heat up behavior. So it's heating up. So it's now at temperature, supposedly. Or not. Wow, that's terrible. And I should point out that it's currently claiming... So, this delta here is 200 degrees Celsius. So that ripple is enormous. Fuck, I just hosed it. I wanted to just save my... Okay, well anyways. Let's cool down. I'll go for 10 seconds. So let me figure out how to get it on the fucking magnet. Alright, now it's cooling down. Better view. I had to move the camera up a little bit. We're not at such an off angle from the LCD screen. It looks brighter from a higher perspective. So remember, it'll cool down to about that bottom grating, you know, the one half of the bottom grating. At which point I'll let it heat up again. So what it'll actually do is it'll cool down until the thermocouple reads 0 or 100 degrees, and then it'll turn off, and you'll see it bounce back up. Okay, so it just turned the fan off. Let's look at the actual settling performance. So it's jumping up easily. Well, I think we're about 50 degrees C per grating. Because theoretically this is 300 and that's 100, which means it jumped up about about 25 degrees, 20 degrees Celsius. Anyways, so heat up performance. At temperature, quote unquote. So it's worth noting that I'm not touching anything right now. So it looks like it's settled by now, roughly. So at this point, it's fairly settled. So let's put it back to sleep. Sleeping. Oh. 150 degrees. Fans off. Well, here's some loop stability over time. This is 1 millivolt per div, so that's half the, it's about 5, 6, 7 degrees C. I'm not totally certain. It's pretty good stability-wise over long times. One thing you can do, is you can see that these are the heater pulses because mine's definitely not very effectively decoupled. But there definitely is not an ideally tuned loop, if anything, nothing else. It stabilizes after it's been sitting heat for a while. It's just right now it's just sitting and running. There's me probing the thing. So yeah. So it's all back together. I can't say I'm impressed. If you absolutely have to spend less than $90 on a hot air station, I guess these are decent. I mean, a lot of this, like the fact that it overshoots and the issues with the thermal lag between the thermocouple and the actual airflow are understandable, if not great. I really, there's probably ways to fix them, but it's cheap. Really, the thing about this that pisses me off the most is, A, the failed segment, and B, the fact that the numbers, the readouts lie. I mean, it snaps to 300 degrees and it just sits there. It doesn't point out that it wobbles up and down maybe 2 or 3 degrees Celsius, which I think that's having an instrument, having some of these design flaws are understandable. It's kind of complex and thermal design is hard. Intentionally bullshitting the LED readouts is just, I mean, it's unacceptable. It's ridiculous. I mean, I can kind of understand, it seems very much like something management would do and the engineers would kind of go, fuck. But, really? I mean, who the hell is competing on, like, do they think that makes them more, I don't know. I mean, I'm going to keep it because I have it, and I don't think I can send it back anymore. And it'll work. I mean, I definitely would really like to put a switch on the front that turns the hot air on and off rather than the magnetic thing, because about a third of the time I put it down, it didn't properly detect it was like holstered. And also, you know, I want, you know, considering the heat up transient issues, I want to turn it on and let it heat up while it's sitting, and then 2 minutes later I come along, you know, much more like a normal one. You know, it also doesn't cool down as far as I'd like. I wish it would cool to like 80 degrees C or something like that. I also really don't like the fact that, like, I have a much older diaphragm pump hot air gun at work, and that one, you know, it would be on, and then you'd turn the power switch off, and it would still run. With this one, if it's on at 300 degrees C and you turn the power switch off, it turns off everything, and it'll probably overheat in the handle and melt something. So the fact that they don't have like a facility to override the heating using this, you know, basically so that they could, or at least override, you know, they could switch the heater with the power switch, but I wish they had like a soft, or some sort of like a relay that's held in until it releases or something like that. Just so that the system will always cool down unless you unplug it, in which case it's easier. But, yeah, stuff. Anyways, I'm gonna go try and stick a thermistor in my, or a thermocouple in my hot plate. So, onward.